Good evening, guys. So, welcome to today's class. So, what we're doing in today's class is this is the first free class for chemistry tutorial. So, we are going to be doing a very important topic. So, and the topic we have before us today is uh, nature of matter and the separation of mixtures. So, those are the topic that we're going to be doing today. But this is actually a free class. We are going to do this in our paid class. We are going to talk about this in a topic. Not that we're just going to be solving past questions, but because this is a free class, we're going to be majoring mainly on solving past questions, and I'm going to try as much as possible to explain them explicitly to you all. So the first question we have before us is: a small quantity of solid ammonium chloride was heated gently in a test tube. The solid gradually disappeared to produce a mixture of two gases. So later a white cloudy deposit was observed on the cooler part of the test tube. So the ammonium chloride is said to have undergone A. Distillation, B. Sublimation, C. Precipitation, D. Evaporation, E. Decomposition. Whenever you see questions like this, when you see a particular solid, this is a solid, right? So this solid, which is uh, ammonium chloride, right? So this ammonium chloride, they said it's in the test tube. Assuming this is the test tube, although there's a particular question I'm going to solve about it on this question. So this is the ammonium chloride. They now said after heating this ammonium chloride, it leads to what? To the solid disappear. This is the solid, right? That is, this is the ammonium chloride. So when they heat it, after heating, this solid it's actually what is disappear. So it now form what? Mixture of two gases. Now, this is how to do this type of question on the cooler part. So this is the cooler part of the test tube. So there are going to be some mixture. So the mixture is going to be around this place. The uh, the cooler part, the deposit, the white cloudy deposit will go and form on this place. I hope you understand what I'm saying. So now, whenever you have a question like this is it. Ammonium chloride. Whenever you heat ammonium chloride, you need to know that whenever you heat ammonium chloride, what is going to be released is uh, ammonia and hydrochloric acid. So when they say two gases was produced, that is mixture of two gases were produced, this was actually the two gases that was evolved. So these are the two gases, ammonia and hydrochloric acid. Now, in chemistry, whenever solid turns to gas without passing the liquid state, so the process is actually called what? Sublimation. I will take that again. Whenever solid changes to gas without passing the liquid state, that type of process is called what? Sublimation. So that's what the question is asking us. They said, which process does ammonium chloride does it undergo? Because ammonium chloride is the solid here. They now said this ammonium chloride become gas. So it means the process, what they are trying to ask us stylishly is that what is the process of converting solid into gas? Now, what is that process? That process is actually called what? Sublimation. So don't forget that when liquid turns to gas, what do we call that? That is evaporation. So let me try to draw it in a place in a way like this. I think most of you already know what I want to draw. You have liquid like this, and you have a gas. Do you get? So if you have it like this, that is solid, liquid to solid. No, solid to liquid. That is solid to liquid. That is melting. So I think most of you already know that already. Liquid to solid, that is freezing or solidification. Freezing or solidification. Now, liquid to gas, what do we call it? That is a evaporation, or it can also be vaporization. So it depends on what you call it. So let me try to write it like this: vaporization or evaporation. Some textbooks we use vaporization, some we use evaporation. So this one, gas to liquid, that is condensation. Then they now say solid to gas, so that will be sublimation. So that's what the question is asking us. So please, whenever you see a question like this, don't run away from it. It's just very simple question. So you can see what they are saying. Decomposition cannot be the answer. Distillation is not used for something like that. Sublimation is the right answer. So let's go to the next question. So the next question states thus. They said a mixture of iodine, a mixture of iodine and sulfur can be separated by treatment of. So what do we use for something like that? So whenever you have a question like this, what are you going to do? They said a mixture of iodine and sulfur can be separated by treatment with A. Water to filter out sulfur, B. Methanol to filter off iodine, C. Ethanoic acid to filter off sulfur, D. Carbon dioxide to filter off iodine. Now this is the answer. This is how to do it. Iodine, you need to look for something that's going to dissolve sulfur. Now what do you think can dissolve sulfur? The answer is carbon 4 sulfide. Carbon 4 sulfide is the what? Is a suitable. This is the formula for carbon 4 sulfide. Sorry, CS2. So that's the formula for carbon 4 sulfide. So it's actually a suitable solvent. It's a suitable solvent for sulfur. Now this is what is going to happen when you dissolve this mixture. You treat it, that is, you mix them together. The sulfur is going to be dissolved. So that one means it's going to like filter off this iodine. So it means the carbon, when you treat a mixture of iodine and sulfur, can be separated by treatment with. So when you treat it with carbon 4 sulfide, it's going to filter off iodine. So that's our answer. Our answer is option D. So don't forget, carbon 4 sulfide is a suitable solvent for sulfur. We have other solvents that we use, like solution of borax in water, all other solvents like that. We have turpentine, we have a lot of them like that. We have petrol, all of them like that. So let's look at this. They said the third question states thus: which of the following is a mixture? Now, whenever you have a question like this, you need to be very, very, very careful. It's very, very simple, but yes, you have to be very, very careful. So the question states thus that we should what? We should which of the following is not a is a mixture? A. Granulated sugar, B. Sea water, C. Sodium chloride, D. Iron filings. Now, this is how to do the question. Now, what is a mixture? Mixture is actually a substance that you can separate by a physical means. So you can use separation techniques for them. Separation techniques like filtration, evaporation, distillation, all those separation techniques, you can use them for them. Now, those are the key words you have to know about mixture is that they don't have what? They do not have chemical formula. They do not have what? Chemical formula. That's the basic thing you need to know about them. Now, look at their option here. Granulated sugar. What's the meaning of granulated sugar? It actually means a normal sugar. Sugar that we eat. And you know that sugar is actually glucose. You can represent it with glucose, or better still, it can still be sucrose. So let's just say sucrose. So sugar is actually what? You cannot say sugar is a what? You cannot say sugar is a mixture, because sugar is actually sucrose, and sucrose is represented by the formula C12 H22O11. So do you get? So sugar is not a mixture. They now say seawater. So seawater, most of you know, whenever you drink seawater, you will see that the water will not be sweet. It contains salt. So seawater is actually, even apart from salt, seawater actually contains other substances like iodine, sodium chloride, water, so a lot of things. So seawater is actually a mixture, and you cannot say that seawater has a formula. So seawater is actually what? A mixture. So sodium chloride, you know that that's actually a compound. Sodium chloride is a what? Is a compound. So that's the formula for sodium chloride. So you also need to know this, that any compound elements, they are what? They are not mixture. So take note of that. So all those compounds, when I'm talking of oxygen, you cannot say oxygen is a mixture. Oxygen is an element, so it's not a mixture. Do you get? compounds like glucose, like sugar, they are not what? Mixture. So what our answer here? Now they now said iron filings. Iron filings means iron elements. So that is what? That is not a mixture. So it's an element. So what's our answer now? Our answer is option B, which is C, water. Let's go to the fourth one. Now this is the fourth question. They say which of the following is a physical change? When they are talking of questions like this, we have two types of change. We have the physical change. These are things you have done in your GSS or secondary school. So physical change and chemical change. So we say that physical change, there are changes that they are reversible. Chemical change, they are irreversible. What else can you say about them? They leads to physical change leads to no change in mass. Leads to no change in mass. But when we are talking of chemical change, there will be what? There will be change in mass. For example, now, if you burn the firewood, if you burn it with fire, it will become ashes. So that firewood will be very, very heavy before you burn it. So when it becomes ashes, we see that the weight will be very, very small. Another thing you need to know about them is that this chemical change, I said it's not reversible like that, alright? Example of chemical change is something like when you burn kerosene. Now I want to ask you something. For those of you that you are old, I'm not talking of some Gen Z that that you were very, most of you, your parents are using lamp. If you are chance to use lantern, you will know that those times when you buy kerosene into the lantern, after you have exhausted the kerosene, can you still get those kerosene back? No. So that's the chemical change. So burning kerosene is actually what? A chemical change. But when you are talking of ice cream, if you look at ice cream, it's actually liquid. But because they want to market it and make it really ice cream, they will now make it solid. So that's actually what? A physical change. So it can still become liquid. If you don't go and take that, if you bring that ice cream close to fire, it will become liquid. So it's actually what? A physical change. So it's a physical change because you can change that ice cream back to liquid. So you freeze it, and you know that freezing is actually what? A particular process. So now look at this. Now they said exposing white phosphorus to air. Now what is white phosphorus? Phosphorus, we have different types of phosphorus. We have the white phosphorus, we have the red phosphorus, and those are we have the allotropes of phosphorus. Do you get? Now when you expose white phosphorus to air, that is a chemical change. I think you get what I'm saying. That is a what? That is a chemical change. Now when you dissolve calcium in water, you know this is calcium and this is water. When you dissolve calcium in water, it's going to give you this compound. Do you get? So just balance it. I think we are balanced now. Sorry, is it balanced? Not yet. I'm trying to balance it. When you dissolve calcium in water, I think it should be something like this. So when you dissolve calcium in water, it will give you what? A chemical reaction, and that one is no more a chemical. That one is no more a physical change, but it's a chemical change because you cannot reverse it again. It is irreversible. So it's actually a chemical. So the answer is what? Freezing ice cream, because ice cream can be taken back to a liquid state. Ice cream is actually liquid, but they will put it inside the fridge or freezer, so it will now become ice. So that's why they call it ice cream. Do you get? That's our answer. So look at this question. I told you when I was doing the first question that this first question is actually the same thing as this fifth question. So you can see, I told you earlier on that solid ammonium chloride. You can see this question, they ask it in different year. I don't just know, they just like sodium ammonium chloride. Now I need to tell you that there are some substances called sublime substance. So what do I call them? They are sublime substance. So these substance, whenever you heat them, they are solid. Whenever you heat them, they will become gas. So that's why they call them what? Sublime substance. So these sublime substance, they are like, I think iodine is part. We have camphor. The camphor, I think you know what I mean by camphor. Camphor is so those things you put in the wardrobe because of the cockroaches you get. So example is also what? Ammonium chloride. So these substances, they what? They will turn to gas immediately when you heat them. So that's something you have to know. You need to know about them. So those are the sublime substance. So now look at what happened here. They said in the experiment above, ammonium chloride deposits on the walls of these two is as a result of what? So the answer is very simple. Just say what? Sublimation. We've already done it. So that's the answer. I hope you guys are getting what I'm trying to say. So please, this type of thing, this type of questions, they are very, very important. I don't just know, they like asking questions or things like that. So please be very, very conversant with them. So we're going to the next question now, which is supposed to be the last question. Another example of sublime substance is dry ice. What do I mean by dry ice? That is solid CO2. So it's also a sublime substance. So please know them and make sure you know them very well. So now this is the last question we're going to be doing for today. Now, but this question is very, very technical because it actually deals with what we call the separation techniques. It's part of the topics we are going to be doing in a paid class. So, but because this is a free class, we are going to be solving questions on it. So separation techniques. Now look at this question. They said a mixture of sand, ammonium chloride, and sodium chloride is best separated by A. Sublimation followed by addition of water and filtration. B. Sublimation followed by addition of water and evaporation. C. Addition of water followed by filtration and sublimation. D. Addition of water followed by crystallization and sublimation. Now, whenever you see questions like this, what are you going to do? Whenever you see questions like this, what are you going to do? So, now let me teach you how to do questions like this. So they now say a mixture of sand. Now I want to ask you one question. Before I do this question, I need to teach you what we call law of solubility. Law of solubility is like actually a law I'm going to teach in the pay class. I'm going to teach them in the pay class. But because this is a free class, I'm just going to I've just touch it on the surface. So look at this law of solubility. Whenever you have this law, it just talks about the salts that are soluble. Whenever you see any sort of sodium, potassium, and ammonium, they are soluble. Any sort of NO3, that is nitrogen 5 oxide, are soluble. All sorts of CO3 2 minus are insoluble, except if they have sodium, potassium, ammonium. Now, I'm going to explain what I'm saying because you are going to be looking at me. What is this person saying? You're going to be looking at me. What am I saying? So all sorts of SO4 2 minus are soluble, except PPSO4, AgSO4, and CaSO4. Although CaSO4 is soluble in hot water, so it's slightly soluble, something like that. So that's just it. Now, what are we going to do in this aspect? Now, let me just tell you about this. let me tell you something about this. Now, this is it. Sodium, potassium, ammonium salts, they are soluble. So what I'm trying to say is, whenever you see a salt like this, sodium chloride now, for example, sodium, the moment you see sodium, these salts will be soluble. I hope you get what I'm saying. Like this now, look at this salt now, ammonium SO4. Look at this. Because you have seen ammonium, this salt will be soluble. I think you get my logic now. Look at this too, K to SO4. This salt, it has potassium. Any salt that have potassium, sodium, ammonium, just know that it will be what? Soluble. Do you get? NO3 now. Look at this salt now. PbNO3 now into brackets 2. Because there's NO3 there, just know it is soluble. I think you guys get what I'm trying to say. So all these things, they are something you need to know, right? So you need to know that this one also is not soluble. BaSO4 also is not soluble. And we also have what else again? So sorry, let's remove this from the. So this one also is also part strontium sulfate, and we also have mercury sulfate. So these are the sorts of sulfates that are not soluble. So please take note of them. So now, so it means whenever you see something like this, whenever you see something like this, just know that now we now say CaSO4 now. All sorts of CO3 are insoluble except those of sodium, potassium, and ammonia. So it means whenever you have something like PbCO3, so this one will be what? Insoluble, without telling you. But if you have something like Na2CO3 now, if this one soluble, you have seen sodium already. Although we say CO3 is not soluble, well, we said except those of sodium, potassium, and ammonium. I hope you guys get what I'm trying to say. So it will be what? Soluble. I hope you get. So it means, but these ones, they will be insoluble. I hope you guys get the logic. So these are just what I want to teach you about loss of solubility. Now let me just clean it. Okay. Now look at this. They now say sand. Now I want to ask every one of you: is sand soluble or insoluble? So it's actually what? It's not a salt. Or can you use it as a salt? No, it's not a salt. It's actually so insoluble. Now ammonium chloride. You know ammonium chloride is represented by ammonium chloride. So that is NH4Cl. Is it soluble? You can see ammonium already, so it is soluble. Now, sodium chloride. You have seen sodium already. So is it soluble? So soluble. Now, they now said, how can we separate these three things? Now, whenever you see a question like this, in which you are seeing that you notice that two salts are soluble and one is insoluble. Now, this is it. If you dissolve these three substances inside water, if you mistakenly go and add water, you have destroyed the mixture. Honestly, you have destroyed this. So if you go and add water, that is actually a wrong thing. You must not add water. So now the next thing you have to think about is, which of these substances that are mixed together is a sublime substance? Now, by now you should know the one that is a sublime substance, because I told you here that ammonium chloride is a sublime substance. So this is actually what? A sublime substance. So it means we have gotten the solution to our problem. Now, what is the next thing you are going to do? Since you know that this is a sublime substance, what are you going to do like that? We just carry out sublimation. Do you get? So this one using sublimation, this one will go out. So you are left with what? You are left with sand and sodium chloride. So what's the next thing like that? You now add water. So in some questions, they will just say dissolution. Dissolution is the same thing as addition of water. So it is called what? Dissolution. Do you get now? So please, whenever you see two soluble substances, don't go and dissolve it. Addition of water, you can see they even put it in the option, because they know some people will go and choose it. So it's wrong. Don't go and choose addition of water. It's wrong. So addition of water cannot be the answer but in the first statement, but it will be sublimation followed by addition of water. Now the next thing you want to do is when you now add water, you will have sand and you have sodium chloride. You have added water now. Now how do you now separate sand and sodium chloride? Because this sodium chloride will have dissolved, sand is going to be showing, right? Now the next thing you're going to do is now what we call what? Filtration. What did I call it? So filtration. So I think most of you know what we call filtration, right? So you have your filter paper here. Filter paper. So you have your filtrate. So the sand will not be your filtrate because sand cannot pass through the filter paper because sand is insoluble. So your sand will be there. Because sand is what? Insoluble. So it will be your residue. To be your what? Residue. Why the filtrates? Will be your what? Will be your sodium chloride. Then you just dry it. Then you get your sodium chloride. Do you get how I did it now? So this will be your sodium chloride. Do you get how I did it now? So that's how to separate this. So if we ask you what's the answer for this question, I think you already know the answer already. Even without telling you anything, you should know what the answer will be. So the answer will be what? Option A. So that will be your answer. So your answer will be option A. So that's that for this free class. Thank you for watching. Bye. So and if you want to learn more about this topic, you can join our paid class. We are going to be talking about this topic in detail because this topic is a very wide topic. So that's that for today's video. Bye.